Okay, so for the warm-up, we were just trying to figure out what f of 18 is, depending on if it's a linear power or exponential function, and the two given points. So let's see, what are our given points? We've got 2, 5, and 6, 20. All right, and we want to find 18. So I'll add that in a bit. First, we're going to look at, okay, for a linear function. So if this function's linear, then that means we've got this plus 4 here. It's going to be an add-add function, or add-add pattern. So 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14, 14 plus 4 is 18, which is what we're looking for. And then, since it's add, the right side we're adding 2, and this is plus 15. So that means this one's going to be 35. 35 plus 15 is 50. 50 plus 15 is 65. So that means that f of 18 equals 65 if this is a linear function. Now we're going to do it for a power function. Power functions follow the add or the multiply pattern. So we're going to look for some numbers that are factors of each other on the x side. So let me erase this. So on the x side, we're looking for a way to multiply our way up. So we want to get to 18. Well, that's a pretty nice jump from 2 times 3 being 6 and 6 times 3 being 18. And then on this side, this was 20. These are different. So then we really only have one more jump. We just need to figure out what are we multiplying by here. 5 times what is 20? That's 4. So 4 times, or 20 times 4 is going to be 80. So then we're going to go over here, and this is 80. And then the exponential function, f of 18, that is the multiply or add multiply pattern. So instead of multiplying on this side, we're adding. So we're going to go back to the 2 plus 4, and so on, all the way down to 18. We're adding 4. And each time we add, we're multiplying by 4. So that means 80 is going to happen a lot sooner for an exponential function than it would for a power function, which makes sense. Exponential functions grow the fastest. 320 times 4, that's going to be 1280. And so that's how you do those. And then now we're going to try and find the equations of these functions. So over, we've got f of 4 equals 20 and f of 8 equals 40. And we want f of 20. So if we're talking about a linear function, what is the equation? So what we're seeing here is for every 4 we increase horizontally, right? X is horizontal, it's right to left. It's the run in the rise over run. We're rising 20. So we can just go straight here and say, well, our rise over run is 20 over 4. So that's equal to our slope, m equals 5. So now that we have our slope, we can plug this into y equals mx plus b and then just pick a point and solve for b. Or we can work backwards in our table because we know that b is what y equals when x equals 0. And fortunately for us, we can work backwards with our same pattern. So this is plus 4, so I'm working this way. So it's 4 minus 4 is 0, so 0 plus 4 is 4. And then this is going to be 20 minus 20, which is 0. So there's actually no y-intercept. It's just y equals 5x. Oh, I wasn't supposed to do that yet. Well, that's the next slide. What we do want to find is 20, though, so we're just going to work our way up. 8, 10, 12, 14, 16, 18, 20. Well, I already know the equation, so I'm just going to plug in 20. When x equals 20, y equals 100. And that would follow if you just added 20 a bunch of times. And if it's an exponential function, I might come back to that, so I'll use a table. It's an exponential function, and we have 4 is 20, 8 is 40. This is exponential would be add multiply, so this is plus 4. This is times 2. So then we want to get down to 20. Well, again, we want to get down to x equals 20. This is going to be a big number. 4, 8, 12, 16. Oh, I put way too many intervals on the last one. 12, 16, 20. And then this is going to be 80, 160, 320. All right, so we already found the linear equation. It was f of x equals 5x. Good work, me. And then now we want to find that exponential equation. So we've seen that we need a starting value. We need the frequency with which it's changing, like how many x's go by until we double it again, and how it's changing. So it's doubling because we have times 2 here. So every 4 x's, we're doubling our f of x. So if we go back to 0, because it's just minus 4, then this is going to be 10, because we're just dividing by 2. Then we've got this equals 20 equals 10 times 2, 40 equals 10 times 2 times 2, 80 equals 10 times 2 times 2 times 2, 160 is 10 times 2 to the 4th, and 320 is 10 times 2 to the 5th. So this is 2 to the 3rd, this is 2 squared, 2 to the 1, and then 10 is just 10 times 2 to the 0, because 2 to the 0 is 1, so it's just 10. So what we're seeing is our exponent is the number that's increasing, so we can already see most of our function is here. It's 10 times 2 to what power, though? We can't just say x, because x is increasing in multiples of 4 over here, whereas it's increasing by 1 in this denominator. So to slow it down, we're going to say x over 4. The frequency is it's changing every 4 x's, so we're going to say x over 4. So 10 times 2 to the x over 4. Let's do another one. F of x has values f of 4 equals 80 and f of 8 equals 240. So first we're going to do it as a linear function. Are we still trying to find f of 20? F of 16. So then for linear, it's just going to be 4, 8, 12, 16, plus 4. That is going to be, what is this, 80 plus 260, or 160. So this is going to be 400, 560. So then we should get 560 right here. And exponential. Use different colors so I can just come back to them. What do we have? 480 and 8240. This is going to be add multiply, so this is still plus 4, but over here, 80 times 3 is 240. So we're just going to keep multiplying by 3, 12, 16. 80 times 3 is 240. 240 times 3 is 720. Times 3 is 2160. Is that right? Yep, okay. So now we want to find our linear equation. So to find the linear equation, we go back to this red table. Once again, we want to find the slope first. And again, that's the rise over the run. Every time we go up, we're going up 60. And we're doing that every 4 x's. So rise is 60, run is 4, or 160, sorry. So m equals 160 divided by 4, that equals 40. And then to find the y-intercept, we can just backtrack minus 4 to 0. And then minus 160, it's going to be negative 80. Negative 80 plus 160 is 80. So it's going to be y equals 40x minus 80. So it's f of x. And then for 8, we're going to do an exponential function. So we're going to do this blue one over here. Once again, we need to find our starting value. So we're going to go back 4 to 0. We're going to divide this by 3, and it's 80 over 3. And then, because 80 over 3 times 3 is 80, it's going to be some weird decimal. I prefer to keep it as a nice and tidy fraction. So, from here, we have our starting value. We can actually just follow a formula at this point. We can say it's tripling, and it's doing it every 4 x's. So we're going to have like 3 to the x over 4. And then we just need to multiply our starting value by that, which is 80 over 3. So f of x equals 80 3 times 3 to the x over 4. Our last set, we got f of 10 equals 100 and f of 20 equals 80. we've got 10, 100, 20 is 80. What are we trying to find? Trying to find f of 40. So 10 to 20 is plus 10. 20 to 30 would be plus 10 again. 30 to 40 is plus 10. If I'm doing linear, it's add, so I'm just going to add on this side too. This is negative 20. It's going to be 60. And this is going to be 40. Just subtracting 20, or adding negative 20 each time. Oops. Where's it, 40? And then for exponential, to find f of 40, here, is 100, 20 is 80, plus 10, so we're going up to 40, 30, 40. Oh, we're not subtracting. So to get from 100 to 80, can multiply by 8/10 or 4/5. 80 times 8/10 would be 640 over 10, so it would be 64. 64 times 8/10, 6.4 times 8, don't know what that is off the top of my head, 51.2. So I made this in the morning, and I totally overlooked that 8/10 can be reduced to 4/5. So we're going to leave it as 8/10 just for the sake of Desmos saying I'm correct. So it's pretty, I guess we're going to do linear first. So we're going to backtrack 1 to find the y-intercept. So this is going to be 120 because we're subtracting 20 each time. And then to find the slope, it's going to be the rise over the run. The rise is negative 20. It's going down 20. It's not rising. Divided by 10. So your slope is negative 2. And then our y-intercept is 120. So we're going to have f of x equals negative 2x plus 120. And then this last one, looking at slide 9, write an equation for the scenario where it's exponential. So let's go look at this blue one. We're going to use that same formula. One thing we need to do is we need to backtrack and find our starting value. So it would be 100 divided by 8/10. That's the same as 100 times 10 over 8. Dividing by a fraction is the same as multiplying by its inverse. It's a little tidier. Equals 1,000 over 8, which equals 125. So then our starting value is 125, so then we're going to get f of x equals 125 times 8/10 is the rate of change. And again, 4/5 is correct. I just didn't catch it. You needed to do these parentheses because when you put a quotient to an exponent, if it's not in parentheses, it won't be for both of them. And it's every 10 x's, which I got from right here. So this is our equation. Again, should have been 4/5. That 8/10 seemed really intuitive to me. And that's that. So good. I'm a little cocky.